In this video, I'll show you some of the safety equipment, glassware, and measuring devices that we'll use in our labs. Now, I expect that you've already read the Laboratory Survival Guide, and I'm not going to repeat much of that material in this presentation. So if you haven't read that, stop the video and go do that now. Now, what I'm showing here in the background is the most important piece of equipment that you'll use in a laboratory: goggles. They protect the most vulnerable part of your body, your eyes. Now, state law requires that you've got to wear these at all times during a laboratory. And that includes in the end when you're cleaning dishes and whatnot. The goggles have to be closed in at the top, at the bottom, and the sides so that they can protect your eyes from spills or spray that comes from any direction. If you've got eyeglasses, those alone are not sufficient protection. So if you're going to work in the laboratory with glasses, you're going to have to choose goggles that are going to fit comfortably over your glasses. There are a few pieces of safety equipment in all of our labs that you should know about. First, eye wash fountains. Eye wash fountains can flush out chemicals that may have splashed into your eyes, but that should never happen, right? Because you're wearing your safety goggles. You can find eye wash fountains in the front of the room. They're in the sinks that are closest to the boards. Look for this sign. Now, it's important that you be able to get to the eye wash stations without tripping over anything. So it's important to take all of your belongings, your backpacks, your purses, whatever, and put them in the cubby holes against the wall and not on the floor so no one trips over them on the way to the eye wash fountain. Now, in our lab, the eye wash fountains are like little shower heads that are mounted on T-bars. There are 2 shower heads, one for each eye. And to activate them, you pull the T towards yourself. Water will spray up out of those shower heads and it'll go everywhere and it'll make a big puddle on the floor. That's okay. You're going to have to flush both of your eyes simultaneously when you're using an eye wash fountain. You have to keep your eyes wide open. That's hard to do. You're probably going to need to hold your eyes open with your fingers, and you're going to need to roll your eyes around to flush chemicals out that may become trapped around the edges. You're going to have to do that for how long? If you read the safety write-up, 15 minutes. You're going to have to do it for 15 minutes. It takes that long to dilute chemicals that are that can damage your cornea down to a safe level. Now, if something dangerous splashes into your eyes, you might not have the calm and presence of mind to make your way across a crowded room and use the fountain on your own. So when something bad happens, it's important to let everybody around you know about it right away. Let them know that you're in trouble so that they can help you. Don't be stoic about it. The second piece of safety equipment that we have is a safety shower. A safety shower can put out flaming clothes or wash off chemicals that have spilled on your head or body. It uses very large volumes of water. A safety shower can be found in all of our labs. They're up near the whiteboard in the front of the room. Look for this sign. There'll be a safety shower in the ceiling, and in the wall underneath it there'll be a black lever that you can pull to turn the shower on. Now, when you come into lab, you should check and make sure that nobody's blocked access to the safety shower. Sometimes people park equipment carts under the shower. That's not okay. Move the cart before you start working. Now, if you're on fire or your clothing has become contaminated with an acid or a base that you've spilled on it, you might need to get that clothing off before you use the shower. The clothes can also be cut off if necessary. There's some scissors that are velcroed to the shower lever for that purpose. To work the shower, you need to find that lever handle on the wall and pull it towards you very hard. It's held in place with a plastic tie-up that you'll have to break. When you pull that lever, it's going to dump 20 gallons of water per minute on you. And it's coming out with a lot of pressure, like a fire hose. So you won't be able to use it as an eye wash for that reason. You're going to have to use the eye wash fountain for that. The shower is going to stay on until you push the lever back into the wall again. Now, a better option if you catch on fire is to use a fire blanket. Fire blankets can be found on the wall just inside the stockroom. They're heavy wool blankets that have been treated with flame retardants. They're in a vertical quick-release red box so that you can pull them out right away. Now, if your clothes should catch fire, what you should do is stop, drop, and roll to put it out. And someone else should go fetch the fire blanket for you while you're doing that. Fire blanket can also be used to put out a small laboratory fire, and they're actually quicker than a fire extinguisher for that if you're not experienced with using fire extinguishers. But use the fire blanket to put out a fire and never a jacket or a towel. If you have a small fire, you can sometimes put it out with a fire extinguisher. You can find those in our labs near the fume hoods. The range and the duration of the spray that you get from a fire extinguisher depends on its size, but usually the spray can only reach 5 or 10 feet away, and it only lasts for 10 to 30 seconds. Consider that carefully before you grab a fire extinguisher off the wall. In the next 2 slides, I'll show you how to choose a fire extinguisher and how to use it. When you're working in a lab for the first time, you ought to take a look around at the fire extinguishers. Note where they are so you can get to them quickly, and know what kind of fire extinguishers there are, because not all fire extinguishers are created equal. Some of them are for putting out particular kinds of fires, and you can make things a lot worse by choosing the wrong type of fire extinguisher to put out a fire. Now, every fire extinguisher is labeled with a class, which is a letter A, B, C, or D, surrounded by a unique shape and a unique color to make it easier to recognize. That's so that you can grab the right extinguisher without thinking about it too much. Now, Class A obviously is for ordinary kinds of fires, wood, paper, textile fires, a fire that would start in a garbage can or a dumpster. They're good for putting out dumpster fires. If you have a Class B extinguisher, that's for putting out things like gasoline and kerosene and oil fires. It prevents flammable liquids from releasing explosive fumes by coating the liquid surface, and that also cuts off oxygen. If you use a Class A extinguisher on a fire, like a gasoline fire, it can blow the fumes up off the surface and can make things a little bit worse. If you've got an electrical fire, it's especially important only to use a Class C extinguisher. Never one of these water or foam extinguishers, Class A or B. Otherwise, the extinguisher spray can complete a circuit through your body and electrocute you. Now, a fire that involves a material that's got a W on its fire diamond, something like sodium metal or metal hydrides, and we talked about these a little bit in the laboratory survival handout that you've already read. That will practically explode if you use a water or a foam extinguisher on it. So you try to put out a sodium fire with one of these, you're going to have an explosion. What you should use when you have a sodium fire or a metal hydride fire is use dry sand or a Class D soda ash fire extinguisher, or use rock salt to smother the fire. Now, you use materials like that when you're doing organic chemistry. You wouldn't have to use an extinguisher like that, a D-class extinguisher in general chemistry ever, because you're novices and we will not give you materials that are that dangerous to work with. Now, you can find fire extinguishers that have multiple ratings. For example, you can get A, B, C combo extinguishers. They do exist, and they're the best choice for a general chemistry lab. And that way you don't have to use a lot of discretion about which fire extinguisher you pick up. We did talk a little bit about how to operate a fire extinguisher in the laboratory survival handout, but let's repeat that. You should remember PASS. That's the procedure that you have to use. First, the P is for pull the pin out. It's got a pin in there that keeps anybody from just casually squeezing the fire extinguisher, a pin like a hand grenade that you have to pull out. The pin is held in there with a plastic band that you'll have to snap, so you have to pull very hard. A is for aim. You should aim at the base of the fire. You don't have very long. If you read the safety handout, or if you were listening to a previous slide, you have a matter of no more than 30 seconds to put the whole fire out. So you've got to squirt at the right part of the fire to get it out. Now, squeeze the handle tight, and that will make the liquid come out the hose. And you're going to sweep it from side to side at the base of the flame in order to put the fire out. Now let's talk about some of the equipment that you're going to be using in these labs, in particular the glassware that you're going to be using. You've seen all of this stuff before if you've taken any kind of high school science. A beaker has a little beak, a little spout, pouring spout on the side. And they're usually made out of Pyrex or Kymax glass, so they're safe to heat. Before you put a beaker onto a hot plate, you always ought to double check and make sure it says Pyrex or Kymax on the side, otherwise it's going to crack. There are volume marks on the side of a beaker, but you shouldn't trust them. They're only accurate to give you, give or take, 5% on the volume, so don't measure volumes in a beaker if you need to know the precise volume. They're fine for doing a recipe very roughly, but don't trust the volume in calculations. They come in a variety of different sizes, and anywhere from just a couple of milliliters up to a few liters. Erlenmeyer flasks are these conical flasks. They've got a flat bottom and a narrower neck, so that you can put a cork into them or a stopper into them to seal them up. They're used to mix and heat solutions. They're usually also Pyrex or Kymax glass so that you can heat them safely. Now, like a beaker, the volume that you read off the scale on the side of the flask is not accurate. They're just for rough estimation of the volume. A graduated cylinder is this long tube with a scale stamped on the side, and it's on some kind of a foot so that the tube will stand upright, and usually it has a pouring spout like a beaker. The volume scale that's stamped on the side can be read to maybe 1 or 2% accuracy, so it's much better than a beaker or a flask, but it's still not the best way to measure volumes. If you need better than 1 or 2% accuracy, more than 3 figures, you should use volumetric glassware. Now, we'll look at volumetric glassware on the next slide, and we'll look at how you read a graduated cylinder in our next lesson. So you don't use beakers or flasks when you want very precise volumes, and you'd probably avoid using graduated cylinders too if you wanted more than 3 figures in your volume measurement. What do you use if you want very precise volumes? Use the equipment that's shown on this slide. Here's a burette. It is a long graduated glass tube with a stopcock on the end. And here it's clamped to a ring stand. This is a burette clamp, and it will clamp it so that it's straight up and down so that you can read it accurately. This is your primary tool when you're doing a type of chemical analysis called a titration. And we'll discuss those later on in the course. It can deliver a precise volume of liquid into a container, usually give or take a few hundredths of a milliliter. And it's accurate to maybe 1/10 of a percent or 2/10 of a percent. You can see exactly how accurate it is because that's stamped usually on the side of the burette. Compare that with a beaker from the previous slide, which I said you can only trust to an accuracy of maybe 5%. Now you find the volume that you deliver by recording your initial volume and your final volume and taking the difference between those two. Here's a volumetric flask, and this is your primary tool when you're making solutions. You pick one of these up off the shelf. They come in a variety of different volumes. We'll use 10 milliliter flasks all the way up to 1 liter flasks. Now, it has a distinctive shape, and it's got a little cap that fits very tightly into the neck. Maybe it's a ground glass stopper like this one, so that when you turn it upside down, the liquid won't leak out. And this is because when you're preparing a solution inside of one of these flasks, you're going to turn it upside down with the stopper resting against the palm of your hand and shake the thing to mix it. And you got to make very sure that when you take a new one up off the shelf that the stopper fits so that you can do that. Now there's a little tiny mark on the barrel called a fiducial mark. When you fill up the flask so that the bottom of the liquid surface, the meniscus we call it, just touches that mark, you'll know the volume of the liquid inside very accurately. And how accurately? Well, usually the accuracy is stamped on the side of the flask. It'll be Class A or Class B. Class A is better and more expensive than Class B. When you want to deliver a precise volume of liquid from one container to another, this is the tool that you need, a glass pipette. It comes in many different sizes and many different accuracy levels. Now here are 3 different sizes of glass pipettes. You'd put a rubber bulb on one end of the tube and you'd suck the liquid up into the tube. You draw it up so that there's a fiducial mark in these too, just like with the volumetric flask. You draw the liquid up above the fiducial mark, and then you remove the bulb and you put your thumb on the end of the tube, and you let air bleed under your thumb until the lowest part of the liquid surface just touches the little mark. Then you take your thumb off and let it gravity drain out of the tube, and then you've precisely delivered a certain amount of liquid. For example, this one on the end here says 40 milliliters, so you're precisely delivering 40 milliliters into another container if you do that. Here is a micropipette. It does the same job as the glass pipettes, but it's got a disposable tip. These are really tough to clean, and this one you just pop the disposable tip off and you don't have to bother with cleaning it. Another difference between this pipette and the glass pipettes that we looked at over here is that it can deliver just microliter amounts of liquid instead of milliliter amounts. So very tiny volumes of liquid can be delivered with this. The volume that you deliver can be changed by dialing up this little thumb wheel. You can turn this like a dial, and then you can read the volume off this readout on the side. So learn to recognize the glassware that's on this slide. This is what you will choose when you need an accurate volume of liquid. Now, suppose you want to move some material from one container to another, and you don't really care about what the volume of that is. You can use the equipment that I'm showing you on this slide to do that. Funnels come in 2 different types that you need to know about. This one's a liquid funnel, and it's something that you'll need when you're filling up burettes and glassware that has a very narrow neck. When you've got a wider neck like this, this is for transferring solids into a container, for powder especially. It's a powder funnel. Here are some crucible tongs. And whenever you've got to pick up something that's hot or contaminated, this is what you'll use. Now, usually a crucible tong is made out of metal, so if you stick it into a flame, it's going to get very hot. And you've got to be very careful about what you put the crucible tong down on top of when you set it down. Just like glass, metal looks pretty much the same when it's pretty hot, and you can burn yourself pretty badly. Put it down on top of a little asbestos pad or on top of a heat-resistant surface. When you need to move some liquid into a container and it's a very small amount and you don't care about the volume, you can use transfer pipettes. Here are a bunch of disposable plastic transfer pipettes. They're hard to clean out, so people just throw them away after they use them. When they're glass, you have to put a rubber bulb on the end of it yourself and use the rubber bulb to draw the liquid up into the pipette. Sometimes you need to take some crystals and grind it into a fine powder, and this is the right tool for that job. It's called a mortar and a pestle. The mortar is the dish, and the pestle is the little grinding tool that fits into the center. Now watch out when you're using these. If you're grinding two powders together, if those two powders can react with each other, you can have a serious problem. It'd be extremely dangerous, for example, for you to try to grind rust together with powdered aluminum. You can get a thermite reaction going there, and that will generate enough heat to actually melt the mortar and pestle. If you try to grind iron filings together with sulfur, like that reaction that we showed you in the video at the beginning of lesson 1.1, that can catch fire all on its own. So watch out when you're grinding things in a mortar and a pestle. So what if you have to mix or grind together two reactive powders? What do? It's a little safer to mix them by pouring them back and forth between two beakers. Even that's a little bit dangerous. That's a kind of a dangerous job to do. Finally, when you've got to mix a solution or you've got to heat it and mix it at the same time, the best tool for that is to use a magnetic stirrer. You put a little tiny Teflon coated magnet, which looks like a little pill, into your solution, and there is a stirring motor inside under the plate here with the speed control, and you can stir at any speed with this. And sometimes it's a hot plate, so you can control the temperature as well, so you can heat and stir at the same time. Now when you dump the solution out, be careful that that little stirring magnet doesn't get thrown away. You can fish the magnet out of the solution or the drain if you've actually accidentally dropped it down the drain with a long plastic stick that's got a magnet embedded on the end. You'll find sticks like that in our lab stuck to the side of the metal fume hoods. And most labs use that same trick to store their stirring rod sticks. So we've talked about how you can measure volumes with different pieces of volumetric glassware. How do you measure masses? You use analytical balances like this. And these are both very much like the balances that we have in the lab. In fact, this is exactly the one that we have in the lab. Analytical balances are used to measure the masses of objects, and they're quite expensive. This one here has got a cost in the thousands of dollars. So it's important to take care of them. With this one, the way you can damage it the worst is to spill something inside the container here, which is easy to do. It's quite easy to clean up. You can take this metal plate out, it comes off, and you can take the little collar off and take even the pan off. Take them out, clean them off, let them dry thoroughly, and then replace them if you spill anything in there. Now this balance can measure a mass to within 1/10 of a milligram. That's about the weight of the ink in the period on the end of a printed sentence. That's how small 1/10 of a milligram is. And it can easily weigh fingerprints. So if you handle an object, it's going to seem like it's getting heavier. So wear gloves when you're using a balance like this. If you're trying to weigh a liquid, the liquid will continuously drop while you're trying to weigh it. So if you've got a wet object or a liquid, you've got to weigh it inside of a closed container so that the weight doesn't keep changing. Now the balance on the left here has got a higher capacity. So if you need to weigh an object that's more than 500 grams, you can't use the balance on the right. You can't use this one. You've got to use the one on the left. Now if you look at the readout on this balance, there's the decimal point right there after the 100. So you can read it out to the nearest thousandth of a gram, the nearest milligram. So it can't be read to as fine a precision as this balance over here. Sometimes that's okay though. Sometimes you don't need to read down to the nearest tenth of a milligram. Now both of these balances have got a blue button on the front. This one's easier to see. It says tare, T-A-R-E. When you press that button, it sets the balance reading to 0. So here's what you can do with that. Place an empty container on the balance pan, press tare, and then it'll read 0, and then fill the container with your stuff. And when you read off the weight, then it's reading the weight of the stuff, not the weight of the container plus the stuff. So that's very useful to use. Now, you might notice also with this balance, with the more precise one, that there's a little level on the front. It's got a little bubble in the liquid there. And for the balance to read accurately, you've got to have the bubble centered in the little circle. The legs on the balance are like little thumb screws, and what you can do is if the bubble isn't in the center, you can turn the thumb screws to center the level. If you're working very carefully, you always look at that little bubble, make sure it's in the center of the circle before you start taking measurements. Also, you don't want to lean on the tabletop because that can take the bubble out of the center of the circle. That ends this video. We're going to see some more specialized equipment in the lab as the semester goes on, and there's a lot more to know even about using some of the equipment we've introduced in this video. But we'll talk about that when we need it.